Welcome back, students. Today we are going to learn about a new chapter, acids, bases and salts. Okay, it's there in your textbook. Chapter number 6, page number 75. So, let us learn about the chapter. Children, there are different substances, as I said, acids, bases and salt, and they are having an important role in digestion of food, medicine and in cleaning products. So let us learn about that. Before to that, let us have mind map. Okay, so acids. What is this acids? A substance that tastes sour is said to be as acids. This acids is further classified into two types, organic and inorganic. Okay, so as the name is mentioned, organic, it is nothing but which will naturally occur in plants and animals. Okay, which will naturally occur in plants and animals. So here they are generally said to be as weak acids. Okay, then they contain carbon, hydrogen and oxygen. Okay, so for example, citric acid, clear? Then above the second part, that is inorganic. Here basically they are said to be as strong acid and they are derived from minerals. So here at least one hydrogen atom will be present here, but no carbon atom. At least one hydrogen atom and no carbon. So for example, sulfuric acid. Okay, so this is about acids. Next thing is about bases. So what do you mean by bases? Substances that taste bitter and feels slippery when touched. Okay, they are having bitter taste and then it feels slippery when touched. So again further the bases are classified into two types, strong and weak base. Okay, so above strong base, they can turn damaged tissue and burn the skin. Okay, so that we should handle it carefully. And then for example, sodium hydroxide. And then about weak bases. Okay, example, copper hydroxide. Clear, children? Yes. Now about the third part of this chapter, that is salts. So what do you mean by salts? Substances formed when an acid reacts with bases. Okay, so the salts, for example, sodium hydroxide. Okay, so they are having two parts. The first part always refer the name of the metal that displaces hydrogen in the acid. Name of the metal that displaces hydrogen in the acid. And the second part always refers to the radical in the acid. Okay, so this thing you can understand when I am covering the particular topic. In this chapter, on the whole, we are going to learn about acids, bases and salts. Clear, children? Yes. Yes, children. Now about acids. Okay, so acids. Acid, it comes from a Latin word acer, meaning sour. Okay, so for example, vinegar, lemon juice. It tastes sour because it has acid. Clear? So now about their types. So basically they are classified into two different types of acid, that is organic and inorganic. Organic and inorganic. Let us learn about organic now. So first about organic. It occurs naturally in plants and animals. So organic acids or naturally occur in plants and animals. The source belong to plants and animals. Okay, they contain carbon and hydrogen atoms. This acid, organic acid, contain carbon and hydrogen atoms. Clear? They are weak acid. Okay, they are weak acid. For example, lactic acid, acetic acid, formic acid, citric acid, and so on. So this is what about organic. The second classification, inorganic. Okay, so inorganic, they are derived from mineral resources. They are derived from mineral resources. So it is also called as mineral acids. Inorganic acids are also called as mineral acids. Clear? They contain at least one hydrogen atom but no carbon atom. At least one hydrogen atom and no carbon atom. Okay, most of them are strong acids. So here, inorganic acid, mostly they are strong acids. So it should be handled very carefully. Okay, so for example, sulfuric acid, hydrochloric acid, HCl hydrochloric acid, and nitric acid, HNO3. Okay, so this is what about inorganic acid. Yes children, now let us learn about properties of acids. Okay, so here they have sour taste. Okay, because of the presence of acids. They have sour taste because of the presence of acids. For example, citric acid. Okay, then they are corrosive in nature. That is, they have a tendency of damaging the surface they come in contact. Okay, so they are having a tendency of damaging the surface they come in contact. That property is mentioned to be as corrosive. Okay, then third point, they are soluble in water. They are soluble in water. For example, concentrated or diluted, anything. Okay, so most acids dissolve in water. So while we are dissolving, always add acid to water. Always add acid to water and not water to acid. Clear children? Yes. Now about pH. Okay, pH is less than 7. Here for acid, pH is less than 7. What is this pH? It's nothing but potential of hydrogen. Potential of hydrogen. So it is a measure of concentration of hydrogen ions. pH is nothing but measure of concentration of hydrogen ions. Clear? So here it's a rule that pH, if it is less than 7, that is acidic. That will be acidic. And if the pH is greater than 7, then that is basic. And pH is equal to 7, then that is neutral. The condition is neutral. So here when we add acid to metal, next property, when we add acid to metal, it will form salt and give out hydrogen gas. It will form salt and give out hydrogen gas. For example, 2HCl plus Mg gives MgCl2 plus H2. Mean to say, hydrochloric acid plus magnesium gives magnesium chloride along with that hydrogen gas. Okay, so this is what about their properties. These are the 4 main properties. Yes children, now let us learn about uses of acid. Okay, so here gastric juices in our stomach contains hydrochloric acid. So it will help in breakdown and digestion of food. Breakdown and digestion of food. Okay, then the second point is about ascorbic acid, that is vitamin A. Vitamin A, ascorbic acid, is basically an essential vitamin. Essential vitamin. Then the third one is about vinegar. Vinegar, which is basically 4 to 6% of acetic acid in water. 4 to 6% of acetic acid in water, and it is used as a food preservative. Okay, next thing is about hydrochloric acid. Hydrochloric acid, it is used for removing rust from iron and steel. Rust from iron and steel. And then it is also useful for preparation of cleaning liquids. Cleaning liquids. The next thing is about sulfuric acid, H2SO4. Okay, so it is also said to be as king of chemicals. King of chemicals. Then the sulfuric acid is used in car and inverter batteries. Clear, children? Now, sulfuric acid is also used in the manufacture of fertilizers, dyes and detergents. Clear? Now, about acetic acids. Acetic acids. Here, they are used as vinegar. That is, it's basically a food preservative. Food preservative. Okay. So, it is also used in, apart from this food preservative, it is also used in the manufacture of ink, dyes, photographic chemicals, pesticides, food preservative and so on. Clear? Next thing is about nitric acid. Nitric acid. It is used in the fertilizers and explosives. Fertilizers and explosives. It is also used in the manufacture of nylon and synthetic fibers. Nylon and synthetic fibers. So this is what about acids and their uses. Now the next thing is about bases. Bases. So bases or the substances which are bitter in taste and feel slippery when touched. Okay, and they feel slippery when touched. That type of substances are called bases. For example, sodium hydroxide, potassium hydroxide, ammonium and calcium hydroxide. Ammonium hydroxide and calcium hydroxide. So children, basically there are two types of bases, that is strong and weak. Okay, and about strong bases, they are corrosive, so that they can damage tissue and burn the skin. Okay, that's why they are strong base. They are strong base. Since they are very strong, we should carefully handle it. Clear? Next thing is about weak base. Weak base, for example, copper hydroxide, zinc hydroxide and ammonium hydroxide. And so many examples are there. Clear? Yes, children. Now about the properties of bases. Okay. So here bases generally taste bitter or slippery, or soapy to touch. Clear? Next thing, they turn red litmus blue. They turn red litmus to blue. They produce, bases produce salt and water on reacting with acids. They produce salt and water when they are reacting with acids. Okay. Bases are soluble in water. They are soluble in water. So they are soluble in water, that's why they are termed as alkalis. They are termed as alkalis. For example, sodium hydroxide, potassium hydroxide are termed as alkalis. Clear, children? Yes, children. Now let us learn about different uses of bases. Okay, so the first thing is calcium hydroxide. First base is about calcium hydroxide. They are strong base and they are commonly called as slaked lime. Commonly called as slaked lime. Okay, they are used in many agricultural pesticides products, and when the soil is more acidic, farmers add this slaked lime so that it will neutralize the acid. Because it is a base, and if it is added to the soil, it will neutralize the acid. Can you understand? This is what about calcium hydroxide. The second base is about potassium hydroxide. Potassium hydroxide. So they this potassium hydroxide is used in the production of disinfectant, liquid soaps, shampoo and drain cleaners. Clear? Third one is about sodium hydroxide. Sodium hydroxide. So basically the sodium hydroxide is a strong base. It's a strong base. They are commonly called as caustic soda. Okay, then they are used in the manufacture of paper, textiles, soaps and detergent. Clear children? Yes. The next base is about magnesium hydroxide. Magnesium hydroxide. They are also known as milk of magnesia. Milk of magnesia. What is this? It is also a wonderful antacid. Means it will neutralize the excessive acidity in the stomach. Excessive acidity in the stomach. It will neutralize the excessive acidity in the stomach. The fifth base is about ammonium hydroxide. Ammonium hydroxide. So this ammonium hydroxide is used in the manufacture of household cleaners and in many other chemicals. Clear? So this is what about the uses of bases. Now the next topic is about indicator. Okay, now let us have a look on the definition alone. Indicator. What do you mean by indicator? Indicator is a substance which when added to a substance indicates whether the solution is acidic or basic in nature by changing its color. Can you understand? So with this color change, we can differentiate whether the respective solution is acidic or basic. Clear? Yes children. Now in the indicator, if there is no change in color, then it's termed as neither acidic or nor basic. Then that is said to be as neutral substances. That is said to be as neutral substances. So there are different types of indicators. It can be either natural indicator or synthetic indicator. Okay, so first let us learn about natural indicator. So what is this natural indicator? There are so many natural indicators. For example, turmeric solution, red cabbage extract, and then China rose extract. What is this China rose? Commonly we will be seeing this flower. What is this? Hibiscus. Okay, so China rose extract, and then these are all considered to be as common natural extract. Okay, next thing is about litmus. And litmus is also one common extract. Common natural extract where the dye is extracted from lichens which changes its color in acidic or basic media. So litmus paper is prepared by absorbing litmus on filter paper. Okay, so how they are preparing the paper? Litmus paper is prepared by absorbing litmus on filter paper, and then they are preparing the paper. Okay, litmus paper. So that litmus paper, if it is treated with an acidic substance, blue litmus turns red. And again, if the red litmus paper is treated with a basic substance, then the red litmus will turn into blue color. Clear? Yes children, now you can have a look on these two. What is this? This is an example of natural extract. As I said now, this is turmeric water solution. Okay, turmeric powder mixed with water. And this is hibiscus water, that is, it's a natural extract. We're just taking the petals of hibiscus and we are boiling it, and then after 10 minutes we are taking the filtered solution, and that is the natural extract. Okay, this is what otherwise said to be as China rose. Clear? Yes children, now you can have a look on litmus paper. Okay, so what is this? This is the litmus paper. We are using this, it is otherwise said to be as pH paper. Okay, so here they are having different numbers and different colors. Is it visible to all? Yes. So here they are having till 14 and each number is having different color. So we are using this pH paper to check the pH of the given solution. pH of the given solution. So you can see the different colors. Okay, and then after dipping this paper in the solution, the paper will show you a color. So with that color, you want to keep here near to that the color, dip the colored paper to this and you want to find out the respective pH. Clear children? Yes. Yes children, now you can have a look on 2 glass of water. Okay. Now in the first glass, I am going to add lemon. Okay, few drops of lemon. Clear children? Now this is a citric acid solution. Is it not? Yes. Now in the next glass I am going to add little amount of table salt. Okay, I have added and I have stirred also. Now, okay, let us check the pH of the 2 solution. One is acid and another one is base. Yes children, now this is the citric acid solution glass. Okay, now we are going to check the pH of the solution. So this is the pH paper. So now I am going to dip it inside the solution. Can you see that? I have dipped? Yes, I have dipped and I can see the color change also. I can see the color change also. Can you all see that? Is that clear? Cream colored it is. Is it not? Now children, you can compare the color what you got after dipping in citric acid solution with the pH paper. Okay, so you can see the color change. Can you see that? So the color is near to pH 5, isn't it? Yes. Yes children, now you can have a look on this. This is a mixture of water with table salt. Now I am going to check the pH of this solution. Okay, so can you see children, I have dipped it. I have dipped it only for a minute. Okay, can you see? Can you see the color change? Yes. Now children, you can compare the color through the pH paper with that of the pH chart. Okay, so if you see this, you can see the color is slightly green, isn't it? Yes, it's near to pH 8. So this is how we are checking the pH value. Yes children, now let us learn about synthetic indicators. Okay, so as of now we have learned about natural indicators like turmeric solution and then hibiscus solution, isn't it? Yes. Now about synthetic indicators. The first one is phenolphthalein. Okay, so about that they are colorless and changes its color to magenta in a basic medium. It will change its color to magenta in a basic medium. Clear? The second synthetic indicator is methyl orange. Methyl orange. So here it changes its color from orange to red in acidic medium and orange to yellow in basic medium. Clear, children? Yes. Now about the next part of the chapter, that is salt. Okay, so as we all are aware about the common salt, that is table salt, sodium chloride. We are going to learn about that is sodium chloride, NaCl. The most common salt known to us is this sodium chloride. Okay, so here we'll get the salt with a mixture of acid and base. So here acid plus base gives you salt along with water. Acid plus base gives us salt along with water. So here we are using hydrochloric acid and hydrochloric acid along with sodium hydroxide as a base. Sodium hydroxide. So with the mixture of these two things, hydrochloric acid and sodium hydroxide, we are getting sodium chloride, that is the common salt, along with that water. This is how in the laboratory they used to prepare the salt. With a combination of acid, base, you will be getting salt along with water. Once again, hydrochloric acid plus sodium hydroxide gives you sodium chloride, that is common salt, along with water. So here the hydrogen from the acid, it's hydrochloric acid, right? The hydrogen part alone from the acid is displaced by a metal, that is sodium alone. Okay, hydrogen is displaced by metal sodium, so sodium comes here. So to form sodium chloride, sodium plus chloric acid, sodium chloride, that's what we are getting as salt, that is sodium chloride. Clear, children? It can also be prepared by acid and a metal. Acid and a metal. Say for an example, hydrochloric acid plus magnesium gives you magnesium chloride plus hydrogen gas. Magnesium chloride plus hydrogen gas. So we can get a combination of acid and metal together gives you out the salt along with water with the presence of metal here. Clear, children? Yes, children. Now let us continue. That is, we got the salt magnesium chloride. So the salt what we obtain has two parts. The first part is the magnesium, which is the name of the metal that displaces the hydrogen in the acid. We got magnesium chloride. The first part is the name of the metal. And the second part is the radical in the acid. Clear, children? So this is what about this. Next thing is about properties of salt. So what do you mean by properties of salt? What are the different important properties? Thus, most of the solid salts have high melting and boiling points. Most of the solid salts have high melting and boiling points. Most salts are soluble in water. Most of them are soluble in water. Next thing, solid salts do not conduct electricity. The salt do not conduct electricity. Instead, the solutions can conduct electricity. Clear, children? Yes. Now, uses of salt. The next part is uses of salt. So the first salt is sodium chloride. It's a common salt. It is used in food to enhance taste. It is basically a good preservative. Then it is also used for making soaps, detergents and other cleaning agents. Clear, children? Yes. Next thing is about sodium carbonate. Sodium carbonate. Here it is used in manufacture of glass. Used in manufacture of glass. It is also known as washing soda. It is also said to be as washing soda. It is used for softening hot water to enhance the capacity of detergent. Once again, it is used for softening hard water to enhance the capacity of detergent. Clear, children? Yes. Yes, children. Now about the last part of the chapter, that is neutralization reactions in everyday life. Okay, so let us learn about that. First, about insect sting. So when an ant or bee stings us, it's painful. So that is because of the formic acid which is present in the ant. Okay, so if it is painful, formic acid is there. So in case if it is there, the formic acid is there, and if you are applying baking soda or base, baking soda is basically a base, isn't it? So if you are applying this baking soda to the formic acid, automatically it will neutralize acid. It will neutralize acid and it gives instant relief. Clear, children? Yes. Now about the second point, that is excess hydrochloric acid. Excess hydrochloric acid which is there in our stomach, which will cause, it can cause indigestion and it's painful. So to treat this, we are intaking antacid tablets, which is nothing but milk of magnesia. The chemical component is magnesium hydroxide. Magnesium hydroxide. So if you are intaking this during this situation, then that will be neutralize the excess acid. Neutralize the excess acid. So this is what about the second point, acidity. Clear, children? Yes, children. Now with this we have come to an end of this chapter. After watching this video, read the chapter entirely so that you can understand well. Okay, that's all with this chapter. Thank you all. We'll meet in the next class.